In this video, we're going to do a couple more examples of financial models. So remember, P is our principal. That's the initial amount that we invest when we're doing a compound interest account. R is the annual interest rate. So we always use a decimal to express that, even though it's always given in a percentage. N is the number of compounding periods per year. So that's the number of times that each year the interest is applied. And T is the number of years that the investment earns interest. So we have this formula for the compound interest. So it's A equals P times 1 plus R over N to the power NT. So since T is our variable, generally, this would be an exponential function. So it's this is our base to the power NT. So let's look at example 3 here. What annual rate of interest is required for an account to triple within 10 years, provided that it's compounded annually? Okay, so here we want to find R so that A is equal to 3 times P in 10 years. Okay, so that means that T is equal to 10, and since it's compounded annually, N is going to be 1, so it's compounded 1 time per year. So then we want to solve the equation. So A is 3 times P, and then it's P times 1 plus R over N, which is 1, to the power N times T, so 1 times 10. So that's going to be 3P equals P 1 plus R to the 10. So we can divide both sides by P, and that's actually going to cancel out all the P's. So we actually want to solve 3 is equal to 1 plus R to the 10. So here I don't have a variable in the exponent. I just have a number. So this is a bit odd, but what I want to do is actually take the 10th root of each side. So the 10th root of 3 is equal to 1 plus R, which means that R should be equal to the 10th root of 3 minus 1, which is 0.1161 approximately. Okay, so that means that the annual interest rate would need to be 11.61%. Okay, so that's converting this decimal to a percentage. So if we have a compound interest account, we have a slightly different formula. So here's where the number of compounding periods goes to infinity. So we compound as many times as possible. So that's A equals P times e to the RT. So for this example, we want to know the amount we would need to invest in a continuously compounded interest account with a 4% interest rate in order to have $600 after 5 years. Okay, so what we're given, okay, so we know that the rate is 4%, so 0.04. We know that it's 5 years, so the T is 5. And we want to have $600, so what they've actually given us is the A value. Okay, and what we want is the P value. And continuously, so because it says continuously compounded, that's what tell us that it's the A equals P e to the RT equation. Okay, so we know that 600 is equal to P times e to the 0.04 times 5. And we just want to solve for P. So P is going to be 600 divided by e to the 0.04 times 5, which is approximately $409.37. Okay, so that's how much we would have to have now in order to have $600 5 years from now. And I think that's all the extra examples we have in this set. So hopefully you are becoming comfortable with these interest accounts and how to compare them.